A warm welcome to all my students. In this lecture, we are going to discuss about switch gears. It is a mandatory part for any power system. Say example, it is a power generating stations which transmit power from the generating station to the destination or grid. When at this process, safety is a vital part when you make on and off the switches. It depends on how much load you are using and how much we are generating. In order to match this generation and demand, we need switch gears. Basically, switch gears are nothing but operatable switches and circuit breakers which ensures three things: control, protect and isolate electrical equipments without any damage to the equipment as well as the operators. These three parameters may look like the same, but it is having its own characters. Based on that, the switchgear assembly has two basic areas. One is power conducting components like switches, which will be on and off to make power flow from source to load, and circuit breakers, fuses and lightning arresters, which are all safety equipments for making hard switching, that is just make it off the circuits. So it will interrupt the flow of electric power. That is one part. Another part is that when you make this hard switching, that is interrupting flow of electric power abruptly, there will be a counter effect to the equipments which has to be controlled. So there is the need for a control system which will protect the health of, or which will monitor the health of the power system, and it will take control actions at the appropriate time, which ensures control and protection. Now we are going to discuss about the components of the switchgear which has power conducting quality, out of which circuit breakers plays a vital role in day-to-day life. First one is MCB, which is the one we see in our day-to-day life. So it is nothing but an electromechanical device which guards the electrical wire and electrical load from overcurrent so as to avoid any kind of fires and hazards. When overcurrent happens, it will cause fire accidents. Overcurrent is nothing but the source is seeing a very low resistance and it is willing to supply more current flow through a load. That is called overcurrent. So this is not needed when you are operating a motor or a device which is in use. It ensures the rating of a equipment. If the current through the equipment is more than the rating, then it is called overcurrent. Say for example, if you are having a fridge which is drawing some 8 amps from your source. Due to some short circuit or some misleading by operators, if it is consuming 9 amps, then the 1 amps will be transferred through the another load, which is a human body or short circuit. So that overcurrent has to be deducted and it has to be cut off in appropriate period of time to protect the equipment from damage. So MCB is an automatically switching off electrical circuit, works in abnormal conditions. In day-to-day life, we will see if some abnormality, that is overload, happens, you will hear a sound which is from the MCB that automatically made off. So how it is working? It will automatically off and it will never be turned on automatically. You need to go and manually turn it on. You do this lot of times. Instead of changing the fuse, you are making use of MCB in home. What it is there inside MCB? It is nothing but a bimetallic strip. Bimetallic strip in the sense it is having two different metals which is having different expansion rate. So when current through the metal heated up the two metals together, one metal will expand in one rate and another one will expand in another rate. So it causes a displacement, and that displacement is used as a switch to make the protection circuit comes into picture. That is, it will take switch off actions. So it is mostly preferred choice for overcurrent and short circuit protection. So the characteristics of MCB is it can be used up to 100 amps, which means the rating as well as the product can support 100 amps to flow through it. Normally the trip characteristics are not adjustable. That is, once it is fixed, that is, the manufacturer fixed the rating and you can't do any adjustments over it. It is having thermal and thermomagnetic operations, which is, if abnormal temperature is being sensed by this MCB, it will take action, and of course for overcurrent it will happen. That is, overcurrent makes the circuit to heat it up and causes fire. Before that, your MCB has to protect your home appliances and your own operators. Next one is MCCB, which is molded case circuit breaker. It is also an electromechanical device which is same as of our MCB, but it is having some added features which make it useful for industrial applications. So MCB finds its application only in domestic appliances, which is in household equipments. But if it is in case of industries, it deals with the high power equipments which needs some more safety as well as adjustability. It is provided by this MCCB, so it guard electrical wires and loads from overcurrent so as to avoid any kind of fire, which is same as that of MCB. Then what it is having extra? Generally, these circuits have thermal current for overcurrent protection and magnetic elements for short circuit release to work faster, which means faster way of response is possible by MCCB, and naturally it is having ability for adjusting the limit of current to make it on and off. It is not possible in your MCB. So the primary functions of MCCB are it can be manually or automatically opens the short circuit or over circuit condition. In electrical circuits, the overcurrent may fault may result in faulty design, which is controlled by MCCB. So the characteristics of MCCB are, it can be used for a range of 1600 amps, and the trip current may be adjustable, and it is having thermal and thermomagnetic operation, which is same as MCB. So the only thing is, it is having more power handling capacity of 1600 amps and the corresponding voltage. So power is equal to V into I, and of course it is having adjustable trip current. So with this two, it is preferable choice for any generating stations and main electrical feeders, etc. So here is the difference between MCB and MCCB. What we mentioned early will be displayed here. So MCB is having a rated current as 125 amps, it is having rated at 1600 amps, and of course it is interrupting current is of 10 kilo amps. So it is of course higher kilo amps handling capacity, it is up to 85 kilo amps. Judging from their power capabilities, MCB is mainly used for low breaking capacity circuits, that is domestic application. It is for industrial applications. It is having a tripping characteristic, normally not adjustable. It is having adjustable trip characteristics for overload and magnetic settings. Next area of discussion is ELCB, which is also a circuit breaker, but it is used for earth leakage. That is, if there is a abnormality due to some earthing issues. Of course it is somewhat older technique, but it is there in existence in very few areas, because of what means it is sensing voltage, not current. As per human body is concerned, if there is a considerable current flowing through your body for a period of time, it will make the body parts to get heated, and naturally it cause heart attacks or some permanent damage to your body before some very small period of time. So this has to be ensured by your protecting equipments. If these equipments are delayed due to their architecture, naturally it fails. So ELCB is also a protecting circuit which senses earth leakage, that is the voltage across the earth. If there is a voltage across the earth, there will be current flowing through it, and naturally that has to be detected and responded. So it need some 0.1 seconds, that is 100 milliseconds, which is enough for the person to feel the shock. So that is a problem with the ELCB, but it avoids the switchgear from circuits against the short circuit and overload protection. There is no doubt of it. But current based measuring devices are more preferable in this case, like ELCB. So another thing is emerging out, which is called residual current circuit breaker, RCCB. Residual current in the sense, after loading your external load, if your ground is having an elevated voltage, that is due to the earth leakage. If your ground is having elevated voltage, that is due to the earth leakage. That is, your earth rod is not properly grounded. So that voltage can induce a current to your body. So that is predicted and rectified, that is corrective actions may be taken by this RCCB by measuring currents, not as voltage by ELCB. So ELCB is now been what ELCB is replaced by this RCCB in new technology. So let us consolidate the difference. So it is a new name and refers to the current operated device, and it is for voltage operated earth leakage device. It ensures 100% detection of leakage current and is available to sense AC as well as DC leakage currents. It is not preferable as it can only detect current that flow back through the main earth wire. That is, if your earth wire is having a current flow, then it will sense. RCCB has no connection with the earth wire, and that's why it can trip when both current, that is phase as well as neutral, are different, and it withstand up to the both the currents are same, which means if an abnormality happens, your phase current has to be equal to, will not be equal to your neutral current. That means you are supplying some current, it is energizing the load, and it comes back to the neutral. So the phase current has to be equal to neutral current. But if you are having a shock, that is, if you are having a overload happens, which means your phase current and the load current will not be equal. It will be somewhat higher. So that is the way it detects and it will make protective action, which is 100% efficient. So ELCB is working based on the earth leakage. These devices measures the voltage on the earth conductor only. So it purely depends on the quality of earth conductor. If this voltage, that is if the earth voltage is not zero, which indicates a current leakage in, which is there is no current leakage in the